The objective of today's lesson is to determine the domain and range of a linear function in mathematical problems, determine reasonable domain and range values for real-world situations. We'll actually do that more next time, okay? And then represent domain and range using inequalities. There's 4 words I want you to highlight. I want you to highlight the word domain. I want you to highlight the word range, the word discrete, and the word continuous. Those are going to be some of the vocabulary words we're going over today that you need to be able to understand. So here's some definitions so we can have it written down. The blank of the function is the domain. The domain is the set of all input values or x values, highlight x values, of a relation or function. This is what you just did with that picture of the puppy. You guys told me the domain. You told me where it shows up on the x-axis. You read that from the left to the right. You told me it went from, I think it was 2 to 11. That was the domain for that puppy. The puppy showed up between 2 and 11. The range, on the other hand, range like home on the range, is the set of all output values, which is your y values, of a relation or function. Range is always read from bottom to top, which is what you just did with that puppy. You guys told me where the bottom of the puppy, where its paws were, and then where its top was. I believe that it was 1 to approximately 16. That's the range of the puppy. Now, keeping all this vocabulary in our brains is a little bit difficult because it's so many new words. So we have this mnemonic device here for you that might help. It's called Dr. XY, where's her ID? So you see doctor, right? And then XY, that's her name. And doctors have to wear their ID badge. The reason that we write it like this is because if you circle the first column of words, the domain is the x values, which are independent values. The range is the y values, which are our dependent values, the outputs. So Dr. XY, where's her ID, is going to help us remember at least which is x and y for domain and range, which helps you eliminate answer choices when we take a multiple choice test. Now, if you notice, those words that I had you highlight from today's objective are also right here, and they have their own little sections, discrete and continuous. There are 2 types of functions in the world, 2 big main categories of functions. One of them is called a discrete function, and one of them is called a continuous function. A discrete function is a relation or function that has values that are disconnected. I want you to highlight the word disconnected. Discrete, disconnected. These are going to be like little dots on your screen, like a scatter plot or something. That is disconnected data, so it is discrete data. We use discrete data when we count stuff, like tickets or people or dogs, because we can't have half a person, half a dog, or half a ticket. You have a whole person, a whole dog, or a whole ticket. Okay? This is what a discrete graph looks like. You see how it's like, a bunch of dots? That's a discrete graph. And when we talk about the domain and range for a discrete graph, all we have to do is count the x values used and count the y values used. What I mean is, and I want you to take your pencil and do this, from every little dot, I want you to draw an arrow down or up to the x-axis. Because remember, domain is my x's. When we draw arrows directly down, it's like columns. The columns that are used for this function are 2, 1, -1, -2, and -3. Normally these graphs have those numbers on there, right? But I just counted like they, it's an axis. So if you look at the description here, it says the x values include -3, -2, -1, 1, and 2. Isn't that exactly the numbers we just put down as columns that we used? So to talk about the domain of a discrete function, you're going to use this list. What do you notice about this list of numbers? Aren't they the exact numbers we just saw? Yeah. We have said that the x values used in this function are -3, -2, -1, 1, and 2. That's what you just told me. This is just like telling me where the puppy shows up on the screen, except they're all disconnected dots. We have to do them individually. If I do the same thing for the range, instead of going down to the x-axis, since range is the y values, I'm going to bring them over to the y values. So everyone draw me sideways arrows until those dots get to the y-axis. From the dots, I'm going over to the y-axis.
Oh, it's going to be like y. It's going to be like x, 3x, you know what I mean? Or 3, 4. Yeah.
3, 4, 5, and what other number? 0. It's on the flat line, so that's 0, right? Again, normally these graphs have like numbers on them, right? But we can count. So the numbers that are used, the numbers where dots show up on this graph are 0, 3, 4, and 5. So if you look at the description of the range, we're just saying that the y values or the range used is the list of those numbers. 0, 2, 0, 3, 4, and 5. Let's look at continuous functions. What is the difference do you see visually from the discrete functions we talked about to the continuous functions? The dots are not separated. Continuous functions are connected. Doesn't matter if they still show you the dots. If the dots are connected, like they've printed a connecting line between them, it is a continuous function. This data is stuff we measure. So things like time and distance, because you can have half an hour or a quarter of an hour or a whole hour, or you can go half a mile, 2.5 miles. You can measure things if you have fractions and decimals. This is what we're going to use for continuous data. Now, the way that we talk about domain and range for continuous functions is a little bit different, and that's more complicated. It's what we'll spend most of today on. But this is really like it's my puppy. So let's pretend instead of this graph, don't draw this, but I'm just going to draw a person right here. Okay. If that was the puppy, the picture that we had earlier, like the puppy, you guys have already answered this. You would have told me that the puppy or this person goes from, this is -2, all the way to what value? Oh, that's +2. You're so right. I put a 3.
So +2, -2.
+2 and -2. That's where this puppy, where this person shows up, right? What about bottoms and tops? What's the lowest that this goes? -3. What's the highest that this goes? 5, right? I think it's 5. But check my math. Bless you. Guys, this is just like the puppy. If this person or the puppy wasn't there, we're finding the domain and range for this particular graph. We would say that the graph shows up from -2 to 2 on the x-axis and from -3 to 5 on the x-axis. Do you agree? Do those numbers make sense to you? The way we put it together is a little bit different. We would say that the x values are continuous from -2 to 2, but we answer the domain is -2 less than or equal to x less than or equal to 2. This is the left and the right number of my puppy or my person. The left number, do you see the furthest left that this went up there? This is the left side, is -2. The furthest right that this went is 2.
Will it always go left to right?
Yes. It's smallest to largest, which is why it's left to right. We will never do right to left because that's biggest to smallest and we don't count like that. So those symbols, what is that symbol called? Does anyone remember the name? Less than or equal to, which means all of the x values have to be bigger than that number, right? Aren't all of the x values bigger than -2? Aren't these numbers bigger than -2? Yeah. But then where does it stop at? +2, because this one says less than or equal to 2. So x has to be between -2 and 2.
So it has to be the same number, I guess?
Not necessarily, because look at the next one. The y values are continuous from -3 to 5. What's the lowest that this went?
-3.
What's the highest that this went?
+5.
That's the range. It's between -3 and 5. -3 less than or equal to y, less than or equal to 5.
So then what would it be equal to?
Why would it be equal to?
What would it be equal to?
Any number between that. So we could pick 0. Is 0 between -3 and 5?
So we choose whatever number it is.
Any number that's within that range, yes. That would be a part of the graph. That's the domain and the range. I understand that this is super complicated. That's why we're spending some time on it. But everybody flip this page over. We're going to go into more detail about the continuous functions because they're a little bit more complicated. Okay, let me help you figure out how to write continuous domains and ranges, okay? This is going to be our biggest step today is going to be continuous graphs with two endpoints. So your endpoints are either going to be solid endpoints like this or open endpoints like this. There's a difference between a solid colored in circle and an open circle like that. But these graphs with two endpoints are like the puppy. They frequently have domain and range in the form box, symbol, X, symbol, box. In those boxes, you're going to write me the left and the right number for the domain, the X's. And then for the range, we're going to do the bottom and the top. Yes, sir. Yeah, so he just jumped ahead a little bit, but you see down here, we're going to fill that in. So if you have just an open circle in my domain and range, I'm not going to put that line underneath the less than symbol. But if I have a filled in circle, or basically anything other than an obvious open circle, you're going to use less than or equal to.
It's one of the things I remember in 7th grade.
Good, I love it. One of the other mnemonic devices that we're going to use to help you remember how to talk about domain and range is called Dolor the Robot. And no, I'm not talking about Pain the Robot for my Spanish-speaking friends, but Dolor stands for domain is the left to the right. That's how we're describing it, left to right. And robot is range is from the bottom to the top. Dolor, left to right. The robot, bottom to top. Okay. For this first example, I actually want you to put your pencils down, and I want you to watch me go through these two examples. We'll do some together, but I think sometimes we try to write and listen and read at the same time. No, I just want you listening and watching, so don't pick up your pencil. Just watch. For this example, I know it's already done for you, but if I was trying to answer the domain and the range, I would, with my pencil, go box in, like we did the puppy, the furthest that this goes to the left. Do you agree that where I put my little green mark is the furthest left it goes?
Mm-hmm.
Where's the furthest right it goes?
8.
8. Do you notice that over here we have a closed circle, and over here we have an open circle? Okay, so look at my domain. My domain is from -8 with a closed circle to 8 with an open circle. Yes?
Wait, yeah.
From -8
Okay.
all the way to 8.
I get it.
Closed circle, open circle. Same pattern every time, right? If I do the same for range, I'm not going left to right anymore. I'm going from the bottom. What number is at the bottom there?
Way to,
What number is that on the y-axis?
0.
0. All the way to the top, what's the top number? 4. Closed circle, open circle. So from 0 with a closed circle to 4 with an open circle. Yes? I want you to notate just like I did. We'll do the second example in a second, so you may pick up your pencils now. Go ahead and fill this in on your notes. I'll give you a second. If we scoot over to the second example, again, I want you to put your pencils down and just watch. Put your pencils down and just watch. If I'm asking you to describe the domain and range for this function, domain is the left and the right. What's the furthest left that this graph goes? 0. What's the furthest right that this graph goes? 5. So our domain is from 0 to 5. If you look at the way I've written it, from 0 to 5, why is this symbol not have a line underneath it? Because the circle's open. And why does this one have the line underneath it? Fantastic. Love it. Okay, let's look at range. Would you agree that this is, nope, wrong thing, that this is the bottom of the graph? That's as low as it goes. No? It goes lower?
No. 1 step lower.
Okay, so I understand. I'm not talking about the coordinate graph. I'm talking about this curve.
Oh.
Is this the lowest that the curve goes?
Yeah.
Okay, cool. Yeah, what number is that? -5, which is why I got this number, and it has a closed circle. Is this the highest that this graph goes? No. What is the highest this graph goes? The curve. It's not always the endpoints that you're looking at. especially when you have curves, you actually have to remember you're looking at the bottom and the top. So that top number is 4. And because there's no obvious open circle, you put the line underneath the symbol. You may pick up your pencils. I want you to fill that in. So I think we need a little bit of help. Thank you for attempting it. I know that this is hard and difficult. So let's look at that first example together. Okay? Because I'll let you try something when you may not have been ready for it. My bad. But also, I'm going to push you like that sometimes. If we're looking at this graph, we know that domain is the left to the right. On the very left of this graph is right here. What x value is that? 1. So I know that this is going to start with 1 because that's the furthest left. Is it -1?
No. Oh, no, it's on the line.
This is 0, so this is 1.
Oh,
I'm not looking at, we're not looking at the y values yet. I'm looking at the x values. Look at the x-axis. Yeah, this will get you. Okay. What's the, sorry, back up. The symbol, it's open. So which am I using? Less than or less than equal? Just less than, because it's open. In between this is always x because we're talking about domain. Then we go look at the right side. What number is on the right side? 4. Is that symbol opened or closed? So I use just less than. And if we keep going to answer the range, what's the lowest that this graph goes to? Right here, isn't that the lowest it goes? Which is -2. And what's the highest value it goes to? 2. So my range is from -2 without an open circle all the way to 2 with an open circle. Remember, it's not always the end points that's the lowest or the highest. You actually have to look at the lowest and the highest for the graph. Because this is bottom to top. Dolor the Robot. Can you guys try the next one? Yes, you can. You got it. Give the next one a shot. So if we go do that second one, our domain. Remember, you're looking at the x values for domain. Domain is the x's. So I look at the x-axis. This one starts on the left at what number? -4, and on the right it ends at 2. So we would say the domain is from -4 with an open circle all the way to 2 with a closed circle. The symbols are important. If you give me a line where the line doesn't belong, it's wrong.
So it goes highest to lowest first. So it's like top to low first. So
Opposite, bottom to top. Small numbers to big numbers. Yes, tell me the range.
2. So this is left or right? Oh, this is down. So the highest point is +2.
The highest point is +2.
It's now it's open, so it's.
Do I start with the highest number though?
No.
No, we start from bottom to top. So what's the bottom? The bottom is -4 with a closed circle with a y in between because this is range. And then your top number that you did tell me with that open circle that you did tell me. Bottom to top. Smallest to largest. Smallest to largest. Let's do this third one together. So if I look at the third one, this burning candle graph, domain is my x's, the left to right. My x-axis is right here in case you don't see it. Which means that where the x value of this graph begins is what? 0. Where does this graph end? 60. So we're going from 0 with a closed circle for the x-axis all the way to 60 with a closed circle on the x-axis. Yes? Left to right. I drag it down to the x-axis. If I switch my thinking and I'm going for the y values, what's the bottom y value? Don't tell me 60. 0, because this is the bottom y value, and it has a closed circle. Range is y's. And what's that top number? 12 with a closed circle. You're telling me where the graph shows up, between 0 and 60, then between 0 and 12. Left, right, bottom, top.
The highest it goes, right?
That's the highest it goes, yeah. Lowest it goes to highest it goes. Leftist it goes to rightist it goes.
Oh, you're right.
Yes? We've got a few more example problems on the other side because we just need to see examples of this. So remember, and I just gave you a reminder here, when we're talking about disconnected or discrete data, you're not going to use the symbols. You put the numbers in a list. But when we are talking about the continuous data, we're going to do the x's from the left to the right and the y's from the bottom to the top for domain and for range. Okay, we're going to do this first example and the second example together, and then I'm going to let you finish this on your own. Example 1, is that discrete or continuous?
Continuous.
Is it disconnected or connected?
Connected.
So it's continuous. That means that we're going to use those inequalities because we have to change our domain and range based on what we're given. So we follow the same pattern we've had all along. What's the furthest left that this graph goes to?
-3.
-3. Closed or open?
Close.
Closed. So that's -3 less than or equal to x. And what's the furthest right that this goes?
4.
4, which is less than or equal to 4. Now, one thing I want you to write, and I know I didn't really leave a lot of space for this, you're going to see verbal descriptions of these domains and ranges. Verbal description means the way we say it out loud or this written in word form. So I need you to write this down. The domain for this function, if I were to say it in word form, is all, this is long, real, that's not how you spell real, real numbers greater than or equal to -3 and less than or equal to 4. All real numbers greater than or equal to -3 and less than or equal to 4. How do you think I formulated from this into those words? Look specifically at the numbers that I used. They're the same exact numbers, right?
Yeah.
The first number is going to be greater than or equal to it because we're saying it has to be larger than -3 from -3 to 4. The highest it goes is 4. So it has to be less than or equal to 4. I am going to ask you to practice putting them into word form. So make sure you have this down so you can see an example. And then let's do the range. You got the range? Where is it from? From the bottom. 0 with a closed circle. All the way to -3?
Wait,
Why?
was it?
The top.
The top was +3.
Oh.
Okay.
Eyes are important.
Let's do again the verbal description for this range because we're going to need to be able to write it. It always starts with the all real numbers part. All real numbers greater than or equal to what number? All real numbers greater than or equal to what number? 0 and less than or equal to what number?
3.
Okay, that's the verbal descriptions. This all real numbers part is the same, and then all that changes is your numbers. So if you see answer choices written out in word form, which you will, that is what we're talking about. It's just your mathematical sentences put into math, like English terms. Okay? We're only going to have time to do example 2. I just want to make sure we have a good example of both a continuous and a discrete, because we didn't do very many discrete examples. But, obviously, what's happening in example 2? Are those disconnected or connected?
Connected.
Disconnected, so it's discrete. I'm not going to use inequalities for discrete data. All I need to do is list out the numbers. Okay, so you make me a squiggly bracket, and then you tell me every single one of these x values that we used. So I draw a bunch of lines down to make sure I know where all of the x values are. That first arrow, the one on the very left, that's at -1, -2, -3, -4, -5, -6. What's the next one at?
Negative
So this is -6. This one's -4. What's the next one? -2. What's the next one?
1, 0.
0. What's the next one?
Positive.
Positive.
Oh, you're right. I put a 1. Boop. 2, 4, and 6. I'm going to scoot this over.
What's that you put at the left?
So that is a squiggly bracket. You, honestly, you can just do like squiggles. We'll get better at doing our squiggly brackets as we practice. We do the same thing, but this time for the range. We're going to the y values now. What's the lowest that this graph goes?
2.
-2. So we have in our range, we have the number -2. What's the next one? -1. And then 0. And then 1. And then 2. And then 3. And then, yeah. It's just a list of all of the y values for those coordinates. The domain for discrete data is a list of the x values, and the range is a list of the y values.